A cliff diver dives off of a cliff 85 feet above the water. 85 feet above the water. If the diver's initial vertical velocity is negative 5 feet per second, so he's going downward, so they tell us right here, 5 feet per second downward, and the acceleration of gravity is negative 32 feet per second squared, or 32 feet per second downward. So that means after every second, you're going 32 feet per second faster in the downward direction. How long is the diver in the air before entering the water? So let's just set a variable t to be what we want to solve for, which is how long is the diver in the air? Let me just write time in the air. Time in the air. And we have the initial velocity of the diver right here, the initial vertical velocity. And that's what we care about. We just care about what's going on in the up and down direction, the vertical direction. So our initial velocity is negative 5 feet per second. Negative 5 feet per second. Now, what's going to be his velocity right when he hits the water, right when he enters the water? What's going to be his velocity? What's going to be his final velocity? His final velocity, well, if he's traveling, he's going to start at negative 5 feet per second. So it's going to be negative 5 feet per second, negative 5 feet per second. That's his initial velocity. And every second that goes by, he's going to be going negative 32 feet per second faster after every second. He's accelerating downward at that rate. So if you multiply the acceleration times time, that's how much his velocity is increased. So it's going to be his initial velocity plus, or maybe we should say minus 32 feet per second squared. That's the acceleration times time, times the time that he's in the air, times this t. And obviously this will be in seconds. So we have 1 second over second squared. You'll just have a second in the denominator. So you'll have feet per second and feet per second. The units all work out. But hopefully this makes sense. He's starting off at moving downward at 5 feet per second. The negative is telling you the direction is downward. So he's moving downward at 5 feet per second. And every second that goes down, so after 1 second, he'll be going 37 feet per second downward. After 2 seconds, he'll be going, what, 32 times 2 is 64, plus 9. He'll be going 69 feet per second downwards. So this is his final velocity. So what's his average velocity? If his initial velocity is negative 5 feet per second, his final velocity is this. And it's a linear relation. At every second that goes by, it's linearly increasing or decreasing if you want to view it as a negative number. So the average velocity is just going to be the average of these two values. So let me write this down. And we're really just learning a lot of physics here, but this will set us up with a nice quadratic equation that we can use the quadratic formula for. So our average velocity is going to be the average of those two velocities. So it's going to be, and I'll skip the units right now, it's going to be negative 5 minus 32 t, all of that over 2. I'm just averaging these two things. That's my initial velocity. This is my final velocity. I'm just taking the average of the two. So this is going to be equal to what? This is negative 10 minus 32t over 2, which is equal to negative 5 minus 16t, right? I'm just dividing everything by 2. So this is my average velocity. Now, we can just apply our simple distance is equal to rate times time. Distance is equal to rate times time. Now, what's the distance that he's traveling in this situation? Well, he's diving off of a cliff 85 feet above the water. So the distance that he's going to be traveling is 85 feet. So he's traveling a distance. He's going to be traveling a distance. He starts 85 feet above the water, but the distance he'll travel, he's going to go 85 feet down. So the distance he's going to travel is negative 85 feet. That when we use negative for down, we use positive for up. Everything in this problem is happening in the down direction. So negative 85 feet is going to be equal to the average velocity. Well, we just figured out the average velocity. It's this thing right here. That's our average velocity. So it's going to be, let me do it in another color. Let me do it in this blue. Our average velocity is negative 5 minus 16t. That's our average velocity. velocity average. And then we want to multiply that times time. Times time. This is our velocity, our rate. That's our rate. And then I'm mixing up the colors. This is our rate, and then we want to multiply it by time. So rate times time is equal to distance traveled. So let's solve for t. And we'll skip the units for now, just because that'll kind of get in the way of maybe the learning. So we have negative 85 is equal to, if we distribute this t, we get negative 5t minus 16t squared. And now we can add 85 to both sides of this equation. Let's add 85 to both sides. And we are left with 0 is equal to, and let's rearrange this. So we'll have a negative 16t squared minus 5t plus 85. So this essentially is the equation. If we solve for t, we'll know how long he's been in the air, because we've used all of the other constraints. So this is a straight up quadratic equation, so we could use the quadratic formula here. So it's going to be negative b. So now what's b? B here is negative 5. So negative b, which is negative 5, plus or minus the square root of b squared. Negative 5 squared is 25, minus 4 times a, which is negative 16, times c, which is 85, all of that over 2 times a. A is negative 16, so 2 times that is negative 32. So the time is equal to positive 5, right? Negative 5 is positive 5, plus or minus the square root of, and we probably want to take out our calculator for this. We have, let's evaluate this. So we have 4 times, so we have a negative and a negative. So those two are going to cancel. Let me put my calculator aside right for a second. So we have negative out here, and then we have a negative. So these two are going to cancel out. So it's going to be 25 plus 4 times 16 times 85. So let's figure out what that is. So if we have 25 plus, I'll put some parentheses here, 4 times 16 times 85 is equal to, so we got 25 plus 4 times 16 times 85 is equal to 5,465. And we can take the square root of this. So let's just take the square root of it, right, like that. And we have 73.9. So let's just stick with 73.9. So this is going to be equal to, let me delete this right here. This is going to be equal to, we already figured out what the square root is. We just evaluated it. We delete that right there. This is going to be equal to plus or minus 73.9, all of that over negative 32. Now, we can add 73.9 and we can subtract 73.9. But what happens if we subtract 73.9? Well, actually, let's think about this carefully. Let's do both of these. Let's just go through them. So the two combinations, so the two possibilities for t is we have 5 plus 73.9, which is 78.9, all of that over negative 32. That's one possibility for t. The other one is 5 minus 73.9. And let's see, what's 73.9 minus 5? It is negative 68.9. Right? 73 minus 5 is 68. Swap the negative, so it's negative 68.9 over negative 32. In this case, the negatives cancel out. So which of these can we use both of these times? Well, this right here is going to be a negative number. And we don't want a negative time. It's definitely a positive amount of time that he's in the air. What he's not, negative time, or we're going back in time, who knows? So we can't even use that. So the time in the air is going to be this. It's going to be 68.9 divided by 32. So let's figure out what that is. So it was that. So it's 68.9. So it's 68.9 divided by 32 is equal to 2.15 seconds. So his time in the air, the time in the air is going to be 2.15 seconds. And we're done.